Guys in the chat, please a round of applause for Thibaut, the CTO of Poppy, the car sharing platform in Belgium. Thibaut, the floor is yours.
Nice. So yeah, hold on. No, wait, this is still in view. Yeah, okay. See my screen, I guess.
Yes.
So yeah, how to build a car sharing platform in Node.js. It's I don't know if it's a good title or not. Basically, I tweeted about what we achieved recently, which is create this new car sharing platform from scratch. And then yeah, you asked me then if I could share a few insights about that experience. So it's going to be a presentation which will be a bit of a mixed bag of everything, which kind of fits my profile. I'm not really a huge specialist of one particular technology. I'm not like an Angular consultant or a Node.js performance specialist. I'm more of a generalist. So first I'm going to show you what we made, and then I'll show you a bit what are the tenets and what are the main pillars of what we think helped in building this this platform. First, I'll show you what we do at Poppy briefly, and then we'll jump to the tech. So obviously we do the mobile app, which is the brand new mobile app that we launched. It's in React Native and Typescript. It's connecting to our API or REST API. So we have launched quite a new features compared to the previous app that we had. Lots of features adapted to Belgium, like bank contact or buying packs, and also quite some B2B features. We also have this other mobile app that is not public. It's called Pops. It's for the fleet specialists, the people who are actually going to fuel the cars, who are going to replace a tire and so on. So they need to have full admin access, if you will, to every vehicle. So they need to visualize on a map every vehicle status, be able, for example, to open the seat of a scooter to replace and to swap the battery, that kind of thing. So this is all linked to our ticketing system, which is based on Zendesk. So this thing is quite smart. It's showing the areas where we have the highest demand and where there's the highest chance of a vehicle being picked up. So when they have to actually rebalance a vehicle, they drop it there. There's also all sorts of techniques to prioritize the tickets based on the location of the fleet specialist. The goal is that people should be really autonomous and not depend on a manager to do their work. Previously, there was a lot of WhatsApp channels to coordinate the work, and now they have this app. Obviously, the back office that we made with a simple React template. We started off with React admin. We were not too happy with the really rigid structure of it, even though you could achieve really fast CRUD stuff with it. In the end, we bought a team on Material UI teams or something like that. So it's a really cool thing to bootstrap. Being really transparent here. So basically, we didn't have to style anything. It's based on Material UI. Really happy with it so far. Picked the wrong team for the screenshot, but it's pretty cool. We have a B2B platform where basically people can switch this toggle on and use their company allowance. So we sign up companies of all sizes. It's well, to be honest, it's mostly one-person companies and mid-market companies, so up to like 20, 30 employees. We don't have any big corporations. These big corporations, usually they use our platform using another payment method, like modality cards or their budget, mobility budget, if you're familiar with the mobility landscape in Belgium. And then we have like tons of APIs. We have a deep integration partner APIs, so you can actually reuse and actually transpose the entire Poppy experience from even unlocking a vehicle on your own app. When we accept it, of course, it's quite a process to be accepted. For example, the Wim and Skipper are both MAS that integrate Poppy. And then we have what we call the MDS API. It's a mobility data specification. It's an open data specification that we have to implement to communicate with all the public authorities. It's pretty important for us to get along with the public authorities. What they demand in exchange is a lot of data. Of course, it's completely GDPR compliant. There's no identifying data that could identify anyone, but they want aggregates and also vehicle data to know how to manage their city, basically. Because after all, yeah, they allow us to operate in their city. And then there's this whole BI thing where I redacted a bit of things here to hide the numbers, but basically we have a BigQuery data warehouse and we have Data Studio for dashboards. So BigQuery is really impressive. That's something I'm really a big fan of that I only discovered recently, but it's a really massive thing. The fact that it's a columnar database that you can basically scale almost infinitely to a lot of data. It's really great, especially since we have IoT and lots of vehicle events. So we have like tables that could potentially be billions of rows. Then we have other integrations. For example, for KYC, we use SumSub for 3D face matching, for accepting people, scanning their driving license, accepting people. We have some marketing automation. IoT, obviously, we're now refleeting the entire fleet with new IoT from Continental. We have some finance and admin automation. So not really interesting, this last part. But. So the team is really short, like I said, we are only 5. Everybody has lots of different hats. There's not really a split between backend and front-end developers. There are affinities though. So there's definitely some people who do more front-end, but everybody touches the whole code base really. And we don't have any product manager or even product designers. Everything is done by us. So we really have multiple hats, which is really cool, by the way. It's a lot of work, lots of stress sometimes, but it's cool to have this level of ownership on the product and be able to really craft the product the way you see it. And I think that's what I was discussing with an ex-colleague of mine from Showpad yesterday. We had lunch and I was saying like it's really cool when a developer can be a bit of a product manager as well, because developers know what the shortcuts can be in the product. Like when you get pixel perfect designs and a way that is completely designed by a product manager that doesn't have any technical knowledge, I think sometimes it's great because they actually have this separate concern, but they sometimes don't figure out that something that might seem huge is actually quite a quick win sometimes, and vice versa, of course. So we migrated from a turnkey solution. What does it mean is that Poppy, until a few months ago, was not using any of its own code. We were using Viewlog, which is a turnkey solution for mobility-based companies. There's like lots of operators that use Viewlog. There's other competitors like Wunder Mobility. And so basically before we were on this state where we were using the Viewlog app with the Viewlog backend, the only thing that we did is download CSVs. We didn't have our own database and just downloaded CSVs, trying to do some dashboarding, trying some scripts, some custom scripts that would call their Viewlog backend, but we did not own our own solution. What we did then is we thought of a smart way to basically migrate everyone is just to make a new app, a new backend, but still use the Viewlog backend behind the scenes. So it was very transparent for users. They could just log in with their existing credentials, existing phone number on the new app, and they will just find back exactly their, we migrated everything, like they saw their trip history, everything. And now we're moving to that 100% ownership phase where we even replace the IoT. So we're completely getting that turnkey solution out of the picture. And now everything is completely migrated. And the cool thing is that we could really take baby steps. there was like no overnight migration where you say like, okay, tomorrow is the day, and we like fingers crossed everything is going to go well. And actually, up until now, again, still now there are only 65% of the people on the new app. There are still 35% on the old app, even though we send them messages and everything. But sometimes people don't just have the time to check it out, what you say, or like, and it's not a big deal. We're going to terminate our contract in 2 months, and we still have some time actually. So what are the 3 main tenets? I mean, we're going to get to the tech part now, more specifically with JavaScript, NodeJS, React Native, Typescript. What are the biggest tenets that I think really helped us with a small team to develop all this? And of course, we took a lot of shortcuts. So it's not like we had this, we had a lot of work, but we took a lot of shortcuts. We used a lot of managed services. We used lots of cloud-based solutions. So first of all, we have a simple architecture. And I'm really of the belief that your architecture should basically fit your team. So we really deemed it early that a microservice architecture, for example, was not for us. That these things are really for like companies that have to scale massively. But of course, we still want to keep that option. So we still try to make some kind of modular architecture. So I'll talk about that. Data is everything. And I'll show you a few examples of where we try to keep our data as sane as possible and as easy to reason about as possible, including TypeScript in that picture. And also, the last thing is to keep it simple as possible. There are many areas where I think, especially us engineers, are really, we have this bias of over-engineering things, and I think we made a good job at making a few things really simple. And I'll explain that there are even some things that I was not convinced about that really turned out to be really cool. So for the architecture, we have a very, very simple architecture. It's basically a modular monolith. That's what I call it. It's like an artichoke, right? So you have this Fastify instance. We use Fastify for everything that is web APIs. And we register what Fastify calls plugins. So it's if you're familiar with Express, it's like middlewares if you want, but they're like sub-servers. So let's say if I want to take the webhook routes and make it its own server and its own deployment later, it's going to be very easy because everything is really separate and everything. It just so happens now to be running on the same infra, but it's going to be very easy to separate it. And so we have this really like very monolith structure, but there are a couple of exceptions. So for example, we have a flag, feature flag service that is completely separate because it's an open source solution that we deploy. We made our own document generation service that makes that outputs PDFs. That things has to be as generic as possible. That it's basically, I don't even know if you can call it microservice, but it's basically very separate from all the rest. So all the clients, mobile app, back office, the partner API, and the third parties connect to this one API thing. It has multiple, if you want, in the Q&A, we can discuss Kubernetes and infra in detail, but basically it's one deployment, but it still has many different point of entries on the network level. So that's why I said it's kind of easy to take it apart. So it has different ingresses and services for everyone. So there's a mobile API, the back office API, the partner API, webhooks. I omitted some, I simplified a bit this schema. And so basically every one of these sub-server, how I call it, has its own routes, its own middlewares, its own controllers with a light business logic, can have access to the data access layer and access to the services where the core business logic lies. And so every one of these sub server, if you will, has this exact same structure, follows the same pattern. So I think it's quite consistent across. We have a few things, miscellaneous things like crons that are deployed separately, but otherwise the main thing is like, I think we have like something like 10 workloads or something on Kubernetes, but the main one is really the API. And then we talk to the IoT gateway from these services. That's also another thing that we deployed. That's a separate thing. And this thing abstracts all the IoT connectors, because we have to connect to multiple IoT brands, like Continental, the old turnkey solution, but also new scooters, Okai kick scooters. They all have their own API, and we kind of want to commoditize this thing and make it really as abstract as possible, and not manage this complexity of IoT here. And we isolate this in its own IoT gateway. Then we have a data layer, very classic SQL, just a bit of NoSQL with Redis, but we only use it actually for, we use it mainly for queues and a bit for cache. But the main thing is really on SQL. So why data? That's the next tenet, is paramount, and I think it's actually a quote. I should have added the author here, but it's a quote from Linus Torvalds. But it's basically that data structures are more important than actual code. Actually, it's not so true if you really dig into what he really meant. What he really meant is that, of course, code is important, but even if you have good code, if you have the wrong data structures, if you have data structures that don't match your domain or what you're going to do with that data, even the best code is not going to fit. It's never going to fly. How we use data is we want to be as typed as possible. And when we started the project months ago, there was this new thing that we already followed. It was done by the makers of graph.cool that we were a bit acquainted with, but never for a production project. Basically, these guys are really like GraphQL folks. It's called Prisma. You probably heard of it. And it turned out in the end to be an ORM. But it's an ORM that is a bit, that it takes a lot of inspiration from GraphQL in the way it structures its schema. This one is a bit, I simplified it a bit, but it's really taking inspiration from what we actually have in production. So basically, you make a schema that looks like a GraphQL schema, and it makes for you, it's going to generate all the Typescript types for you and generate all the constructs to access your data. And I think ORMs are like a double-edged sword. I'm not always a fan of ORMs. I think ORMs are really good for like 90% of the cases where you do CRUD stuff anyway. Then we fall back when we can, when we have to, when performance is really important, or when we have to do some GIS, geometrical calculation, we fall back to SQL, because of course we use Postgres as a database, and it's a flavor. I mean, there's an extension of Postgres called PostGIS that we use. You probably heard of it as well. And basically that allows you to have these geometry types. And these are not actually supported by Prisma itself. So we have to fall back anyway to raw SQL very often. But like, I think most of the back office is using Prisma, and probably like 70–80% of the SQL queries that we make on the mobile API as well. It's a lot of Prisma, and I think it's great for the velocity of the team. One example is, so if you see this kind of schema, you see the kind of code that it generates for you. It's a lot of boilerplate that you avoid, basically. It's going to generate for me like this type trip that has exactly what, I mean, the data looks a lot like what my database has, like this UID is not nullable, but this trip path is a string and it's actually nullable in the database. So it's gonna appear so when I do everything, when I do my requests. And so same thing for my create input. So when I actually add data in there, it's going to know and it's going to be smart about how I can create data that respects the limitations and the constraints of my database. I'm just going to quickly demo a bit Prisma if you don't know it. For the rest, I apologize for the repetition. It's going to be quite a simple thing. Oh, hold on. So this is basically their starter package, right? They have this database. So we're going to use just the user and the post here. So a user has multiple posts, basically. And so it's pretty cool because here what you're going to do is you're going to have this find many thing, and you're going to say, I'm going to include the post of this user. So basically you make a join. It's pretty straightforward to read, but then the type is going to be smart about it. It's going to know that if you look at the definition of the type, it's a user, but it also has a post array. And so whatever you do here in your query it's going to be reflected in the type. And if you want to make some smart types, like if I wanted to actually type this, I could say that these are didn't capitalize that, but basically you can say like I'm going to include the post, and that's going to be a user with an array of posts as well. Now, what I like about TypeScript as well is that sometimes you want to return a response that is not exactly your database, right? So you're not gonna, for example, we use UIDs and integer IDs. We don't want to include the integer IDs for security reasons. I can make like an HTTP response. So I'm going to use Lodash. So it's kind of a parenthesis about this Prisma thing. It doesn't have anything to do with Prisma, but Lodash is also very smart about types. Its type definitions are really good. TypeScript made a lot of progress in dynamically typing things. So for example, here, if I omit the ID of my user, I'm going to only have users that have no ID, right? They only have email, name, and post. Because, and so this type security, this type safety is really good, and it's very easy to compose as well. When you have many types in your schema, you end up with like users that includes their entities, that can be the trap, of course, of ORIPs is to make like huge joins. Always have to be careful with that. But I think it's a very cool choice that we made with going the Prisma way. They have a migration tool as well that we don't use. We use a classic migration tool called NodePG migrate, but their migration is also pretty nice. So I recommend, if you don't know Prisma, I recommend you check it out. If you do NodeJS things on the server, it's really nice. You get up to speed quite quickly. And so on the if we get back to data is stored like we just saw with Prisma, that is stored and consumed from SQL, but it's also exchanged through an API. And so one of the things one of my teammate Simon, to name him, was really bullish about, and I really thank him for that, was to have a really good data validation. And that's actually one of the strengths of Fastify. Fastify comes with batteries included in some respects. I mean, it's not as opinionated, for example, as Nest, but it has more stuff, like, for example, than Express. One of the reasons they do API data validation is also they actually use that for performance as well. So they actually want to be able to deserialize faster, and they use JSON schema for that. So they use AJV, sorry. which is based on JSON schema by default. We use Yup. There's also Joy from Happy. We use Yup, which is really that simple, as they say. It's a really cool validation library. And so what we're going to have with that is that we're going to define a schema that is going to really constrain and put boundaries in what you can accept in your API. And the thing is going to be smart about it and basically tell you that you have an invalid payload if you don't respect that. And the error message is going to be quite clear as well. So here you can define, of course, it's here it's a back office schema to create a new credit pack. So we request that the user inputs a lot of things. So here we do validation here as well. So there's the validation obviously on the client, but we do this validation on the server as well, obviously. One of the cool things is that you can infer the type and it's going to reflect in TypeScript. And I think that's also very powerful. I'll show you how it looks like on our own code base, actually. So here you can see the exact same snippet that I showed you on the slide. And you're going to see that since this schema has required fields, an integer that is required, here another integer, a string, 2 booleans. This one is not required, entity target. So you immediately see when you infer the type, that the entity target is a string, but it can also be undefined. So that's exactly what we saw in the schema, and that's really great because I really have the insurance, the assurance that I can rely on the data that I have as an input, and I don't have to create a lot of boilerplate for data validation. And all these things are of course typed to the correct type. Like strings, number, but it can be a very complex object as well. It can be an array with objects and specific properties. It can be custom. Yup is very flexible to define your own custom types. Can take enums, whatever. It's very good. So that's about it for data. That's two of the topics I wanted to talk about for data with Node.js. Another tenet is to keep it simple, and I think that's also, for example, if you take search, imagine what I started on investigating when I thought, okay, we need a search, right? Like the back office needs this search feature, and it has to autocomplete. People are going to look up plate numbers, the name of people's, the emails of people's, because they need to, like, they work every day on that back office. So at first I investigated, like, yeah, let's deploy Elasticsearch, let's deploy these crazy technologies that do everything and the coffee with it. And Elasticsearch is really great, by the way. Of course, it does a lot of good things. It's very performant. But then you start thinking, okay, I'm going to have this Elasticsearch thing. I'm going to deploy it on my infrastructure. It's going to be, or I'm going to take it even managed. It's very simple to have an Elasticsearch server up and running. But then I have to build this index. So it means I have to like add triggers in my database on Postgres. And then this thing has to rebuild the index each time something changes, or modify the index each time something changes. So after a day of work, I thought, yeah, I mean, I'm nowhere. And this thing, we don't have a huge appetite for search neither. I mean, it doesn't have to be, I mean, it has to be fast. But for example, does it have to support fuzzy search? Not necessarily. So what we started doing is we investigated a way to do it with SQL, and there's actually a pretty simple technology. It's called the trigram technique, and basically it's going to create an index on every field that you want to support using trigrams. And so what the trigram is, and it's as simple as that: you create the extension PG trigram. You create that index, and you say like which field you want to index. And so, for example, if my name is Thibaut, T-E-E-B-O-T, it's going to create the trigram T-E-E, the trigram E-E-B, trigram E-B-O, etc. And so you do just like, you keep your query still very simple. It's still a very simple like, but the query execution is very different actually. I'm going to show you why it's different. So just to illustrate what I meant by a trigram. So if you were to visualize that index from the table, that's what you would get, like ATT, COM, EWC, EWT. I'll show you how it looks like in JavaScript later. And so if we look at a very simple scenario where I don't know if I made this, I'm going to start over, I'm going to delete the table. So I have this simple scenario where I'm going to create our table. It's actually like the schema that you saw. I'm going to insert in it like a few data. Now I refresh, check my users, and you see I have like 3 last names. If we select this thing, yeah, it works. It works pretty well. Will it work with a million rows? It will probably be slow, especially if you do a lot of these requests. So if you want to explain this with an explain statement, you see that it's actually going to iterate through 210 rows. So it's going to iterate through, or the 3 rows, the only 3 people that I selected, it's going to actually go over it 210 times in total, and the complexity is quite big. So now I'm going to create that index. So now it's building the index, right? It's building all the trigrams from the last name of these 3 persons. And here you're going to see that the difference is mind-blowing. Like it's only iterating through 3 rows because we have 3 people. So it's gonna scale really well with the number of data that you have. And if we look at the data that we have at Poppy, we have like lots of users. We have the luck to have quite a nice volumetry. It's gonna make a difference. So that's how it looks like with Prisma, but it doesn't have anything to do with Prisma. It's just that that's one of the row queries that I was explaining that we do very often to make SQL. And by the way, this is pretty cool because still Prisma here is going to like check for SQL injections and that kind of things with templated strings. And so here we're going to check multiple tables, and this query is super fast. Like it's going to check the phone, the email, the first name, the last name, the email of a user. It's going to, on the one search, it's going to check the plate of a vehicle. It's going to check the name of an entity if you have a business, and it's really fast. Like the autocomplete is really good. We have like sub 50 milliseconds response times with this. It's including HTTP transactions, so it's really good. So it's really a big shortcut when you think about it. Like it took us, I don't know, just a few hours to put in place to have full text search. Of course, there's like, it doesn't compete completely with Elasticsearch. Like if I misspell completely a name and I type it completely, it's not going to find misspellings, for example. But with the appetite that we had, and I think we always have to think of like, what is it that the products need? It's actually really good, and the users never complained about the search. It's actually pretty good. Another one is PDF generation. That's also something like how are we going to generate our invoices? Next click of mouse, like, yeah, you should include this CRM thing, and then it's going to make the PDFs for you, or include that PDF composition library made in C++ or that kind of thing. But it's also a very tedious task to integrate, and so we thought, yeah, actually there is a really fine way to create these documents. We know a document generation model, right? It's actually the browser. It's actually using HTML, sorry. And so what we do is it's something I actually stumbled upon. I found a pretty cool repository. I forked, and then we pushed it further. It's basically that we launch Puppeteer. We render a template with the data that we get, and then we pass the data through the URL with the data text HTML encoding. So we don't have to create a network request or whatever. We just give the data through the URL bar. Like if you paste it through to your URL bar, you will get the same result. And then after that, we ask simply to Chromium to generate a PDF. And so that was also a pretty cool shortcut. Also something that you think that actually, at least I did think that it would take us quite some time for a small feature, but it's yeah, it's actually very reliable, and it took us only a few hours. So we always look for shortcuts like that. That's what I really meant by keep it simple. And when you look at it, it's I'll demo it a bit. So probably, oh yeah, I know what I did. Sorry, I was trying to do something clever. Bear with me for a sec. I need to remove one thing. So that's the whole code, basically. It has an HTML page with the style, yeah, in the HTML itself, and then it's just I forgot the name of the templating. It's mustache or it's handlebar. It's called handlebar, and so it's very close to HTML, and you just for each in it and show your all your invoice items, and basically that's almost all there is about it. If I launch it, I'm gonna get that's one of the things we made as a separate service. It's in JavaScript. This is the only piece of JavaScript that we have. So if I preview it, it's very easy to iterate on it. So I can modify that template and refresh. I don't have to compile PDF with a C++ library to wait for like exactly which margin it will look like. If I want to preview it, I just hit Command P, right? I just want to preview it. That's exactly what we're going to do. And if I even we can use it in production. Yeah, this tunneling thing. Yeah, I'm going to tunnel the PDF generator service. So this is actually from production. If I send it my payload with all my entity, my invoice, and my trip, it starts Puppeteer and it sends me the PDF. And so I made a few tests with actually printing this thing, and prints really well. So that's also one of the shortcuts that we took. Okay, so for the mobile app, there's also something that I was actually against it. I mean, I wasn't convinced about it. So that's a very interesting thought process. It's app state management. Like, do we need it? I was a front-end developer before as well. So I mean, I went through the whole Redux thing. I was advocating a lot for it, etc. So I mean, for me, the default choice was like, yeah, we use React Native on mobile. Let's use, let's use Redux. And Arnaud, who's my colleague, was actually telling me like, we could do without it. And I said like, okay, you're gonna use these new hooks like use reducer, etc. at the time. And actually, there's a really cool library. There's actually two of them. I think it's a React Query and SWR. So we went the SWR way. And basically, what we do is we use async storage for fast boot, but we use caching and async storage very sparsely because it's always a very dangerous thing sometimes, caching. And we don't have any state management, so no Redux. And the state, basically we accept that the state always lives on the server. And so when I mentioned SWR, it's because why we use it, it's because it's caching requests. And the cool thing about it is that it simplifies your code a bit, and it simplifies, it's easier to reason about your code when you're thinking only in terms of HTTP API requests, because after all, HTTP API requests are really the source of truth. That's exactly where, when you modify something, the fact that you modify it on Redux, and you try to mimic the state or try to sync the state or catch up to the state of the server with like optimistic updates and that kind of things. I mean, it's very often a recipe for having stale state or state that does not exactly reflect what is actually on the server. And when you refresh, you have something different. So SWR makes that very, very trivial to do. So SWR, basically, it's a React hook. You give it a key, and the key is the URL. And so what's going to happen is that the cool thing, what it does, it's a bit hard to describe what it does. Basically, it's not a fetch. It's not a fetch library. It's actually going to use fetch by default, the basic fetch by default. What it does, it's going to cache your data, and it's going to know when to revalidate your stale data. It's going to also give you a few like ease of use kind of things, like deduping the requests. When you make a lot of the same requests, it's going to reload stale data when you get back to the focus of the window. It's going to allow you to be offline with stale data, and then when you come back online, it's going to refresh the data. So it's going to do all that for you. And when you think about screens, front-end screens that you have to implement, I mean, sometimes, or very often actually, and that's a bit why we have these state management libraries to start with, is we have state that is distributed all across the app and sometimes in the same screen. So I'm going to use actually calls from the user in multiple places of my app. And so here we're going to isolate this and put it in its own hook called use user, and it's going to display the data from that user call in multiple places at once. But it's not going to make multiple calls. It's only going to make one call actually, because this thing is going to dedupe the request. And so, for example, and it's also really cool for composition, because if we need a user when we need a trip, we can compose multiple hooks together, because we always need a user when we fetch the current trip, for example. And so that's one of the few options of SWR. You have this deduping interval. So it means that within 2 seconds of rendering your screen and making the first call, it's not going to make multiple calls to for example, /API/user. It's going to only make one call. And then you have all these convenience things like revalidate on focus, true by default, revalidate on reconnect, should it retry when there's an error, etc. There's like tons of options, and it's basically a really cool companion to your fetch library, whether it's fetch or Axios or node fetch or whatever. And so we use it actually on both front end, so the back office web app, and also on the mobile app on iOS and Android. And so far it's been really a really cool experience. And I wasn't convinced at first. I was really skeptical, and now I'm pretty convinced by seeing it in action. So yeah, that's about what I had to say about AppState. It was quite a ride to make this up from scratch. It was 6 months of intense work, and now we're getting to a point where we have a really stable app, and most users are quite happy with it. And we're quite confident that by using these principles of like always having the data sane, always maintaining a good data repository, taking shortcuts where we can, and thinking like simply, and having a clean, simple architecture, we're going to keep that velocity, because that's the important thing as well, because it's very easy to have a fast velocity when you're starting on a greenfield project, but it's very often difficult to keep. And so now it's going to be, the next challenge is to know like how we're going to scale, because we're going to scale probably our engineering team soon, wink wink, and we're going to scale also our operations in probably new cities next year. And yeah, we're basically going to have to try to scale this to a higher level. So when I said, for example, no microservices, maybe there will be more microservices. So when I showed like our basic search, maybe we will need Elasticsearch at the end. But the thing to keep in mind for us is to really keep our feet down to the ground when it comes to technology. So that's about what I had to say tonight. So like I said, it's a mixed bag of a lot of different things, backend, front end, and I have an appendix if you want to. I mean, we're gonna have a Q&A session, but I have an appendix if you want to discuss other things. I have some subjects. For example, we use Redux with Bull, which is a pretty cool queuing library. We use lots of things on Google Cloud, on the Google Cloud platform. So if you want to talk DevOps, it's also an interesting topic with how we containerize NodeJS, how we actually scale this horizontally. Yeah, feel free to shoot any interest you might have about Poppy. We have plenty of anecdotes as well. Thank you.
Thanks a lot, Thibaut. It was really a really nice talk. And yeah, actually,